our tutorial, Dispersion Measures. Descriptive statistics consist of quantitative or qualitative data population or sample frequency distribution, central tendency measures, dispersion measures, association measures, and frequency distribution shape. This topic is part of Business Statistics with our course. Feel free to take a look at course curriculum by clicking the link at the description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of forecasting, business, trading, or investment advice. Please read full tutorial disclaimer at the end of this video. Dispersion measures consist of data population or sample variability. Main dispersion measures are standard deviation, variance, and average deviation or mean absolute deviation. Standard deviation consists of square root of average data population or sample square dispersion. As a formula, to the left we have the population standard deviation with the Greek letter sigma, which is equal to the square root of 1 divided by n, that's the number of observations within the population, multiplied by the sum from the first to the last of the differences between the data within the population minus its arithmetic mean, and that result to the power of 2. To the right, we have the sample standard deviation, which is equal to the square root of 1 divided by n, number of observations within the sample, multiplied by the sum from the first to the last of the differences between the data within the sample minus its arithmetic mean, and that result to the power of 2. Variance consists of average data population or sample square dispersion. As a formula, to the left we have the population variance with sigma squared, which is equal to 1 divided by n, that's the number of observations within the population, multiplied by the sum from the first to the last of the differences between the data within the population minus its arithmetic mean, and that result to the power of 2. To the right we have the sample variance, which is equal to 1 divided by n, number of observations within the sample, multiplied by the sum from the first to the last of the differences between the data within the sample minus its arithmetic mean, and that result to the power of 2. Mean absolute deviation or average deviation consists of average data population or sample absolute dispersion. As a formula, to the left we have the population average deviation, which is equal to 1 divided by n, again numbers of ratios within the population, multiplied by the sum from the first to the last of the absolute value of the differences between the data within the population minus its arithmetic mean. And to the right we have the sample average deviation, which is equal to 1 divided by n, number of observations within the sample, multiplied by the sum from the first to the last of the absolute value of the differences between the data within the sample minus its arithmetic mean. Great. So let's go out into our studio so that we can study dispersion measures with greater detail. Perfect. So here we are within our studio. In this tutorial, we'll be working within our tutorial Dispersion Measures code file. So the first step within the tutorial is to load its packages. For this tutorial, we'll be using QuantMod, and we are loading it with the library command. So we select this code line here, and then we click Run or Ctrl-Enter on the keyboard. The following step is to create data for dispersion measures calculation, which is going to be done through data reading. For this, we create the object named data, which is equal to read.csv, and within it we have the name of the data file, dispersion measures data, as a plain text file with .csv or comma separated values and stored within the working directory, comma header equals to true. So we select that code line and click Run or Ctrl-Enter on the keyboard, which is equivalent. So notice that this created a data object within the global environment as a data frame. So the following step is we click on the spreadsheet kind of icon. So this opens this window with the data, and as we can see we have two columns of data. The first of these dates with a daily frequency from the beginning of 2007 all the way to the end of 2015, therefore 9 years of data. And then we have SPY adjusted. SPY corresponds to the ETF investment vehicle, which intends to replicate the Standard & Poor's 500 index, and adjusted because this includes adjusted close prices, which were adjusted for dividends and splits. So the following step is going back into the code file. We're going to create a new object named SPY, which is going to be equal to an XTS or extensible time series. So we're going to create it with the XTS function, and within it we have data, and we select the second column with those adjusted close prices, comma, order by equals as date with capital D, data the first column. So we select the code line, click run or Ctrl enter on the keyboard, and notice that this created this new object within the global environment named SPY, but now as an XTS. So again, we open it, and we see the same data, but now the dates became its index. So back into the code file, the following step is we're going to do the calculation of daily returns. For this, we're going to create the object named rspy, which is going to be equal to daily return function with capital R of SPY adjusted close prices. So this is going to calculate the daily arithmetic return of those SPY adjusted close prices. So we select that code line there and then click run or Ctrl enter on the keyboard again, which is equivalent, which creates the object named rspy within the global environment. So now that we have the data ready, we are going to do the calculation of dispersion measures on those daily arithmetic returns. So we're going to do the calculation of sample standard deviation, sample variance, and sample mean absolute deviation, or sample average deviation. So first we begin with sample standard deviation, which is what we calculate here, and we're using function SD of those rspy, which are the daily arithmetic returns. So we select the code line here, click run or Ctrl enter on the keyboard, and notice that it prints the result of that corresponding standard deviation. Then we have the variance, which is calculated using the function var of those daily arithmetic returns. So again, we select the code line, click run or Ctrl enter on the keyboard, and we see the calculation being printed within the console as well below the standard deviation. Now we have the variance. And last, we have the mean absolute deviation. Again, all of this sample standard deviation, sample variance, and sample mean absolute deviation. For the calculation of the mean absolute deviation, as we can see here, we have mean and within parentheses AVS, or the absolute value of the differences between RSPY, which are those daily arithmetic returns, minus their arithmetic mean, calculated with minus mean of those RSPY. So we select the code line here, click run or Ctrl on the keyboard, which is equivalent, and notice again within the console the result being printed. So here we have the results of sample standard deviation, sample variance, sample mean absolute deviation being printed. Excellent. So now that we finished studying dispersion measures, let's go back into the slides. And as mentioned previously, this tutorial has an educational and informational purpose and doesn't constitute any type of forecasting, business, trading, or investment advice. Please pause the video now so you can read the full tutorial disclaimer. Okay, so with this we finish this tutorial. Thank you for watching.